Hello everyone, welcome to this presentation about our early research on using refactoring code changes as an indicator of design trade-offs. I'm Schweizer and I will also be attending the Q&A session to take your questions. Design decisions are important to understand why the source code is how it is at any given step in the evolution of the project. This information is usually acquired latently by developers working on the project, growing as they spend time on it. There is multiple cases where easy access to design information is important. For example, during onboarding for new developers to be able to contribute effectively. It's also important for establishing a consistent code base, as similar part of the source code should have coherent designs. Finally, it plays a crucial role in mitigating design erosion and design evaporation where design information is lost over time for various reasons. Indeed, when developers leave the project, forget design information, or when the documentation, if it exists, gets outdated, it's much harder to have access to this information. Sometimes it's possible to recover it. One way to do it is to sift through version history, trying to look at significant design changes in the source code. However, this process is tedious, confusing, and very time-consuming. We're aiming to automate this process by highlighting versions with major design decisions. You can think of it as a kind of supercharged Git blame. So how do we get there? Well, there is multiple steps. Finding design decision is a rather hard problem unless the developers carefully label each change, which is largely not the case for the majority of software projects. We theorized that design decision can be inferred from conscious design trade-off made by developers when they commit changes to the source code. In turn, this trade-off may be inferred from fluctuations in internal quality metrics in the committed changes. But how can we know that the trade-offs are intentional and not just the result of random metric fluctuations? Well, we know that refactoring is a conscious maintenance activity. So we propose to scope these design changes to commit containing refactorings. Specifically, in this explorative study, we're aiming to see if fluctuation in internal quality metrics in commit containing refactorings can be an indicator to find design trade-offs. To do so, we first extract the commit containing refactoring with Refactoring Miner, a tool developed by Nicolaus Zafeiris' team at the University of Concordia. After that, we automatically compute the metric fluctuations for all the commit containing refactoring using metric history, our extensible open source tool designed to collect and process software measurement across multiple versions of a code base. The measurement itself is delegated to SourceMeter, a third-party static code analyzer, but it's very easy to integrate your own or your preferred analyzer as well. Then, we explore the pattern created by the metric fluctuation and try to classify them. In order to build a ground truth to compare the metric fluctuation against, we analyze manually each refactoring commit to find if there was a design intent from the developer for the changes. This is by far the longest step as it requires extensive human intervention. Finally, we examine the correlation between the metric fluctuation patterns and the commit containing design intent. As a study subject, we selected G3 chart as it's well known in the research community and its size allows for non-trivial quantitative and qualitative analysis. Overall, we analyzed more than 3,000 commits. 64 of these commits were identified containing at least one true refactoring. We selected 4 internal quality metrics to evaluate for the fluctuation representing respectively coupling, complexity, cohesion, and inheritance. We found 3 interesting patterns. Quantitatively, we found that about a third of the refactoring commits had no internal quality metric changes for the selected metrics. Additionally, we observed that monotonic changes in one direction for one or more metric account for the majority of commits. Finally, we found that only 9% of commits have metric trade-offs. It's also in this commit that the manual analysis often revealed a design intent. This last pattern is thus very interesting, although we found that commits with monotonic changes for multiple metrics could also contain design changes in rare cases. In the paper, we detail these design changes in selected commits and explain how they affect the metric to create trade-offs. For future work, we're first looking at including other internal quality metrics to see what is their effect as fluctuation on the detection of trade-offs. We're also looking to increase our understanding of metric fluctuation on their relation to design trade-off by looking at a more representative sample of projects and exploring fluctuation in context other than refactoring. Finally, we're also planning to explore other indicators of design decision, such as design principle like solid, technical depth, and pull request discussion to complement the result yielded by metric fluctuations. The first key takeaway is that we found that the pattern containing metric trade-off seems to be a promising indicator for the presence of design trade-off. Additionally, we found that a small portion of commit with monotonic changes for multiple metrics contains design trade-off for the 4 internal quality metrics selected. Finally, we found that a third of the refactoring commit seems to have little impact on quality on the metric studied. Regarding artifacts, we contribute our extensible open source tool Metric History that we use to automatically mine the source code of GFreeChart across its entire version history. We also contribute an open access dataset of metric fluctuation and annotated refactoring commit for the GFreeChart project. Here are some of the topics I'd love to discuss with you in this session. Additionally, if you're interested to learn more or want to discuss, feel free to reach out through my email or Twitter. Thank you for your time.